Figure 9.4, demonstrating the class member access operators dot and arrow. In this example, we're going to take a look at a simple class called count that is fully implemented, by the way, in the same source code file with the main program that's going to work with it. And basically, we've kept this all in one file just because it's a mechanical example to demonstrate for you the different ways that you can interact with an object in C++. So let's first take a look at our class called count. The class has a public section and a private section. In the private section, we have just the integer x, which is our piece of data for an object of this class. We also have a setX member function, public member function that receives a value and assigns it to x, and a print member function that can display the value of x. So it's a pretty straightforward little class. Remember, by the way, when you fully define a member function like we are here, inside of the class, then the member function is also implicitly inlined by the compiler, or can be implicitly inlined. So let's go ahead and take a look at our main program now. In main here, we're declaring several different types of handles for interacting with objects of class count. First, we have an actual count object called counter, and because we didn't provide a constructor in this example, the compiler is going to create a count constructor for us. However, the one that it creates, the so-called default constructor, is also not going to initialize the data member x to anything, so we will need to assign it a value, which we'll do with our setX member function. Now, on line 30, we create a pointer to a count object. Counter PTR is a pointer to a count object, and we're initializing it with the address of the counter object that we created at line 29. So counter PTR points to counter. And then finally, we have a reference to a count object, which we're calling counter ref. If you ever declare a reference variable locally in a function, you must initialize it in its declaration, as we are doing here. And the reference is now an alias for the counter object. So anything we do to counter ref is also being done to the object called counter at the same time. Now, at line 33, we say to set x to 1 and print using the object's name. So here we're demonstrating in lines 34 and 35 how to use the dot operator with the object's name to call a member function to, in this case, set the value, and then again to print a value. Now, if I take a look at the first part of the output, we see set x to 1 and print using the object's name, and we get the value 1. And that's as a result of line 35. Next, we say set x to 2 and print using a reference to an object. And you can see that we use the reference the same way we use the name of the object. Reference name dot and the method, or member function rather, that we wish to call. So when we say counterref.setx to 2 and counterref.print, we wind up displaying the value 2 in the output, so you can see 2 here. Separately, had I just said counter.print, that would also display 2, because counter and counterref are the same thing in this program. Counterref is just another name for counter after declaring the reference back at line 31. Now, when you're dealing with pointers to objects, you do not use the dot operator. You use the arrow operator, which is a combination of accessing the object and dereferencing the pointer as well. So when I say counter pointer arrow set x, that first dereferences the pointer to get me to the object that counter pointer points to, according to this, the counter object, then allows me to invoke the member function directly on that object, setting the value of x internally to 3. And when I want to then call print, counter pointer arrow print dereferences the pointer to get me from the pointer to the object, and then enables me to invoke the print member function. And you can see that indeed we displayed 3 in this case. So this program is just, again, a mechanical example to show you the different ways of invoking member functions, accessing class members through a name of an object, a reference to an object, and a pointer to an object. And we'll be using all 3 scenarios throughout many of the remaining lessons.